Hello and welcome back to Speed Freak Garage, home of power sports on YouTube. We're here with our 1987 Porsche 944S. Her nickname is Porsche McPorscheface because I couldn't come up with a decent German female name that I liked. So our goal today is to prevent our hatch locks from leaking water. So if you have a normal 944 and you're going to be using your hatch locks, then unfortunately the best way to fix it is to replace this rubber here, replace this rubber here, and replace this rubber here. And I hate to tell you, but $100, $100, $100. The most blatant, complete ripoff. It's just awful. Now, because this is going to be a race car, and of course I left my example all the way across the room, because this is going to be a race car, it is required by the FIA and the local rally racing rules that you cannot have any locking mechanisms on your hood, doors, or hatch. That somebody has to be able to get into the car to either shut your fuel off or save your life or pull a fire extinguisher or med kit out. You can't lock anything. So you have to use these. I'm going to use 4 of them because of how heavy this hatch is. I'm going to mount them probably here, 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 and here. I'm still working on how that's going to work. So I'm going to completely remove this locking assembly. And you can see I already gutted the interior assembly. So this specific engineering journal is completely useless to somebody who's going to use this hatch lock. If you're going to use something like this, in this case, this is a genuine Sparco product. I double and triple and quadruple check since Amazon's completely unreliable these days and they sell Chinese shit with the same brand name and packaging. But anyway, so this is going to be, I don't know which engineering journal this is, but it's P1, 2, 3, 4, 5, 7, part number 7, and this is hatch lock seal. Hatch lock seal. So the first thing to do, and it's going to kind of suck because this light's shining right in my eyes, but is to figure out if I can remove this, is it going to cause a leak from up here? And if not, then can I just cap this off with a 3D printed cap and some silicone and call it a day? Which is my primary goal. My secondary goal is to create a cap that actually goes down, you know, that dips down so this lock clears the 3D printed cap, but then water would pool in the cap. Also, if you don't have this seal fully sealed, 100% water and airtight sealed, then the vortex off the rear wing or whatever you want to call it, tail of the car, the vortex will actually lift your exhaust fumes up and right into the hatch, and you're not going to have a good day, which is also why the taillights have to be fully sealed properly for water. I'd like to shoot my exhaust out the side, but you can't do that because there's interior stuff in the way. I might be able to shoot my exhaust out there, but the torsion bar is in the way, so we're still working on that. We can't shoot it out in front of the driver door because that's illegal, and this car, being a rally car, has to be road legal. All right, anyway, so the first step is to get this disconnected, and it looks like it's a triple square. Now, if you haven't heard the term triple square before, then you've probably never worked on your Porsche before. It is a wonderful little proprietary driver set that obviously is extremely expensive and even more expensive than Allen or Torx. That's used in many places on the car that are extremely questionable. So you're gonna need this. And then I'm gonna have to, of course my 3/8 is missing. So I'm gonna have to hunt it down right here. Okay. Ooh. All right, so we're going to remove this lock, or we're gonna attempt to. It might be smarter for me to use an impact, but I don't think triple squares like impacts. And of course it's a freaking 1/4 inch. So stupid. I hate triple square. Just because you make something exclusive doesn't mean it's high quality. Porsche. Okay. Hopefully this thing isn't frozen in place. I apologize. Normally I have my tools closer to my work area, but everything's everything's a complete mess right now because of the engine build that we're waiting on oil pump bolts, which is frustrating that the oil pump and timing chain kit didn't come with oil pump bolts. And those oil pump bolts are apparently special order. At least from the dealership I was at, they didn't have any within a couple 100 miles, so they're coming from a long way away. So we take these out, and I am going to try and reverse engineer this. Man, it looks like it's pretty stuck in there. Let's see, I might need a Again, I apologize, my toolbox is so far away from the workspace. I don't have any, everything's a mess. Yep, it's a 13, what a surprise. Man, I am so surprised. Not really. Okay, so we're gonna loosen that all the way up. Oh, well, I didn't need to do that actually. Just broke it loose. So it looks like this piece actually, this piece here, oh, this is not gonna be fun. Yeah, I don't even think I could 3D print something this complex, at least not with an extrusion printer. I mean, I could print it up, and then, yeah, because the seal where this attaches, just literally, it looks like there's gunk in here. I need to, somebody maybe tried to repair a leak the wrong way at some point in time is what it looks like to me. Yeah, there's that welding from the OEM. Man, what a shit job. Yeah. So this block is gonna go down in this recess, which means I need to 3D print this, you know, enough room for this block to sit. And it also means we're gonna have, oh boy. Yeah, they don't make this easy. I think removing this is the right thing to do though. And I'll design this in 3D CAD. Unfortunately, it's pretty ate up, but I think I could at least help somebody get the 3D CAD, and then if they wanted to take it to a 3D printer that was a little more skilled, meaning that the 3D printer isn't a extrusion based, but like a HP printer or some high dollar shit that can print flexible polyurethane or TPU, thermoplastic polyurethane, then they could probably have a seal printed. And I guarantee you, especially since I'm doing the CAD myself, which the CAD designing is the most expensive part, that the it would be way cheaper than $100. It'd probably be like $10, I would assume, no less or no more than $10, because I just can't imagine it being any worse than that. That's what a magnetic parts tray is for. Okay. Just, oh yeah, not like I just vacuumed that or anything. Okay, so now I have both of these. They are perfectly, wow, that one's really torn up. Are they not symmetrical? Uh-oh. Ooh, they're slightly angled. Huh. Oh hell, I need to keep those as far apart from each other as I can, or I'm definitely gonna get them mixed up. So I don't think there's any L's or R's left after all this time. Man, it's like a metal, it's a metal rubber composite. Still not worth $100. You're never gonna convince me of that. So now the next step, yeah, there's like somebody was trying to repair it with epoxy. That's pretty shitty. That makes my job way more difficult. Damn it. I'm gonna have to. And I need to get an accurate measurement, so I'm gonna have to scrape that off real quick. I have a putty knife hiding somewhere. Scrape, scrape. And it looks like I might have to 3D print a little piece to go over this in order to seal properly, or just do what they did and use some putty. But man, I can't tell if that's hard. That's hard to tell. Sorry, this was supposed to go a lot smoother than this, but obviously in the real world it never does, right? There was a flashlight around here somewhere. There we go. Oh yeah, somebody just shoved a bunch of putty in it. Of course. Well, it looks like there's seam welding and putty, so I might have to get somebody out here with a wire wheel. There we go. Yeah, so there's some seam welding, which we can't do anything about. And then there's putty from somebody trying to make a cheap-ass repair. Okay, so that's a seam weld. That's a seam weld. Definitely will need to 3D print something to help this gasket not get torn up. It shouldn't be that hard. It's just staring into this freaking sunlight. Okay, that's pretty clean. So, my workbench is a disaster, by the way. The whole shop's a disaster right now. So anyway, so this thing, keep all of these here. And if any bolt on this car that I take out that's a triple square, I am not putting a triple square back. I'm gonna go get a normal, either a normal socket head bolt or a normal hex head bolt at the highest possible grade. So I think it's like, what, 12.9, and replace it with that, because I hate triple squares. Okay. So it looks like this lock hole is just kind of stamped into the body, and it is symmetrical. I can tell just by looking at it. And it's also a nice simple square. So we have the square, and then we're going to have radiused corners. It looks like the front radius is a little sharper than the rear radius. So, and I know it's dumb to write with a blue pen on blue paper, but I couldn't find a black pen. So, and then we're going to use the 3D printer's own properties of how basically anything you print is going to shrink. Even if, depending on the material, it could be a little bit or it could be a lot. So, we're going to use that to our advantage and let it shrink. We're going to allow it to shrink. We won't compensate for it. And what that'll do, so 75.92, that will allow us to fit just a little bit of silicone sealant to make sure that we keep all the nasty stuff out. Okay, so 75.92. And then this will be a little harder because I already installed the seal, but try not to mess up the brand new $100 seal. 33.63. 33.2. I'm gonna go with, let's do 33. See, these weird dimensions, a designer didn't choose 75.9 millimeters. He probably chose 78 millimeters, and the car has just gotten a little old. Or the paint on it. Shit. I'm gonna do 33 on this. I'm gonna make it a little extra small because this seam is in the way. So now we need to know how much room we have around the hole, right? So on the sides, it doesn't matter, but on the front, we have very little room because this seal here is in my way. I would say we have 4 millimeters, and I'm gonna butt it all the way up to the seal so I can be sure that it's sealed. So we have 4 millimeter, and that's this dimension. And then this dimension, we have a little more room to play with. I don't want it like stupidly sticking out the back of the car, but at the same time, I don't want it to be like too, and yes, this is scratching the paint, so I don't need to get yelled at about that. It's a race car, not a show car. 7 millimeters, I would say 7 millimeters would probably be too noticeable. I can go down to 6 millimeters and we'd still have, let's say 6 millimeters. We'll try that. 6 millimeters. Whoops. And we'll probably have to print more than one prototype, of course, but we'll see. So now the problem is this freaking thing. I could try and print an exact match for this inside of here. However, if I do that, then how would I describe it? Then if it moves a little bit, especially because I have to realign the hatch because the hatch is out of alignment, and then if other people have a hatch that's a little twisted, so my thought, and really if you, right now it's not even coming anywhere close to the, well, and it's because my hatch is out of alignment, so just to give me a little break on that, but no, it's dipping down in there. Yeah. And I think I'm gonna have to 3D print myself a new one of these, which my printer can't print that long, so I'll have to glue it together, or I don't know. And I'm not paying $100 for this little piece of rubber. That's complete, it's just a ripoff. Because you can literally fire up the rubber mold and make 1,000 of them in a day for 10 cents each. So trying to act like it's because it's an old car is completely false. That rubber mold still exists somewhere, and they can make as many as they want, and they choose not to drive the price up. Okay, so I'm gonna make a full height safety margin for this thing because it looks like it's gonna need it. And it's kind of tough because, see, 7.45, it's at an angle. It's at a pretty good angle. Let's see, maybe I can do this a little more intelligently. What am I doing wrong here? There we go. $12.45 minus 6, so 7 point. So I'm gonna do. We're gonna dip down 8 millimeters, and that'll be like the full length around it. So it'll be like a pocket, 8 millimeters deep, which may hold a little bit of water, but I don't feel like it'll be a big deal. I wish there was a better way to do that. And then for over here, for this spot where we're gonna have, I can almost guarantee we're gonna have issues with this harsh welding cutting into the seal. I'm gonna design a cover for this. So it'll be a square. Oh, I almost forgot the radius on the corners before we. So corner radius is kind of a guessing game. For example, this looks like an 8 millimeter radius, and this looks like a 8 millimeter. The problem with corner radius is if the corner radius is too small, then it's really not going to fit. But I think 8 millimeters all around. Should be pretty good. Okay, now for the counterpart, which unfortunately, wait. Ooh, I almost made a big mistake there. That's, I forgot that's tilted in multiple directions. 9 millimeters. 9 millimeters. Man, they just don't want this to be easy. 16 minus 7. That's 9 millimeters. And I don't know if I can 3D print a cover for this because of the way it's angled. Because it's going to be, well, okay. Let me try. I'm going to try. So I'm going to do a square. A rectangle, sorry. Do a rectangle. It's 53.8. 53.87. 53.87. And the problem is it's got this little weld on it, so getting an accurate measurement off of it won't be easy. 18.65. Okay, and then I think the corner radius is pretty small. Say 4 millimeter corner radius all around. Luckily this TPU is pretty reliable when you print with it. Okay, now the angle, so this is where you'll have to mirror it, but that's pretty straightforward. So the problem we have is that we are looking at, kind of goes like that. So it's got a height here and a height here. Then I also need .14. Every time I measure this shit, the measurements change. It's driving me crazy. 8.96. And then we need to know this pinch weld kind of chamfers out. So we need a nice, it's going to be really thin. I mean, this is probably going to be, let's see, a single print layer, 0.4, 0.8. It'll probably be either 0.8 or 1.2 millimeter thick. It'll be super thin and flexible, so it'll seal good. But we need like a skirt that's chamfered, but then, oh man. Okay, we're gonna try it this way. We're gonna try a skirt that's just super simple for now of 6.66, so 7. Okay. And then we need to know our hole sizes in positions. That's going to be a little tough. So hole size can get off of this, which is going to be 6 millimeter. So the hole size is 6 millimeters. And the position looks like it's held pretty constant from the outer right and outer left side. So the whole position, and this is just a guessing game at this point, it's going to be super flexible, so we should be okay. 7.68. So I'm going to say 8 millimeters because I don't see why a designer would choose such a weird number. I'm going to say 8 millimeters for the holes. So the hole, we got the angle, and then we can create a shell feature to give it the thickness we want. And then printing it's going to be an absolute, almost impossible, honestly, to 3D print. These are going to actually, now that I look at it, just having the little dip down in here to compensate for that is going to make it a lot harder to print. I'm talking a lot harder because of the way the 3D printer works. Oh, this is gonna... Well, I can at least design and print. Try to print the design. If not, I'll have to change the design, but... Okay. I think that's everything I need to get this underway. So I'm gonna shut the camera off while I clean up a little bit out here, and then I'll catch you guys inside, which will be to music because I don't have a microphone for my computer right now. Yeah. Okay, so now that we have our design, it's time to 3D print. So block off airflow. When you're using a thermoplastic polyurethane, you do not want to find out the hard way, like I did, that you need masking tape to protect your print bed. So we're gonna get our temperature of the bed up to 60 C to help avoid warping and to promote adhesion. And then think what we're printing is small enough that we can get away with just a single piece. Now obviously I just put my skin oil all over it, so now you want to, I need to stop wasting these blue towels, but they're so useful. Get a little bit of alcohol, and you want to make sure that tape is stuck down and free of oil. So, and then you can clean off the rest of the print bed. I probably forgot to clean it last time. So now, for those of you that are going to ask, why is everything in this bin? It's because you're supposed to keep your filament in an airtight bin. This isn't airtight, but it's close enough, with gel packs, this little desiccant gel, to prevent water from absorbing into your filament. And when that happens, well, you can bet that you're going to have problems, because when water is inside your filament and you heat it up to 220 degrees Celsius, it's going to cause problems. So keep your filament dry. If you notice your filament making popping sounds, then you need to throw it in your oven and dry it out. I've never had to do that, luckily. I keep a really close eye on this desiccant, and there's a lot of it. So in the desiccant, it's easier to dry that out in the oven than anything else. So now the next thing we need to do is unload our old filament. So I'm going to go to settings. This is a Prusa, P-R-U-S-A, Prusa Mark II-S. It showed up like a day before they announced the Mark III, and I'm still livid about it because the Mark III is so much better for almost the same cost. It's kind of so anyway, settings, temperature, nozzle. The nozzle temperature for this is 220, and the nozzle temperature for the stuff that was in here was 215, so it's okay to just go ahead and crank it right up to 220. So yeah, I'm gonna get ready here. So oh, and then I need to settings, live adjust Z. So I need to push my Z up 0.1 millimeter to adjust for the thickness of the tape. Otherwise you could cause a crash. And you have to make sure to adjust it back down too when you're done, or then it won't stick to the print bed. So my live adjust Z is adjusted for the tape. Now once this hits about 180, I'm gonna pull it out, and you don't yank it out, of course. I'm gonna use the control panel properly, but I don't want it to be too hot because then it'll like stretch and it'll be a lot harder to clean the nozzle out. I'm gonna go 160, not yet, 170. Okay, so unload filament. And look at that, pops right out, nice and clean. Actually looks like it was already a little hot for what I wanted, but so now this filament you can't just shove in because it's flexible. You can't just shove it in like normal filament, so you got to hold it out and then go to load filament. So it'll spin really fast, wait for it to stop spinning fast, and then put it in, and then it'll feed in slow and shove out the old filament at the higher temperature. And so I'm going to take the GoPro off so you guys can kind of see what's going on here. So I'm hoping I'm aiming where I want to be aiming. So eventually it's going to start coming out. I might have to just give it a minute. Okay, that was a little weird. Try it again. There it goes. So now we're pouring our filament out, and you can see it changing colors. So the problem is just because it changes colors doesn't mean the nozzle is clean and ready to go. So we are going to okay, so we're gonna say yes, the color is clear, and then we're gonna load again because it goes a lot faster when you restart the program. And so then I got my giant tweezers, which are super awesome helpful. You guys need these. Like, I think I just searched large tweezers and I got, what are these, like 11-inch tweezers? Yeah, nice, helpful. Spatulas, woodworking tools, wire cutters, leftover zip ties. Excuse me for a sec. Excuse me, sorry, fighting a cold. So it's gonna go through its routine. You can see we wasted some filament, but trust me, it's worth wasting the filament because you're cleaning out the nozzle to get a nice clean start. So you can just stick this stuff over here. Now, yes, the color's clear. Okay, so now we can print from our SD. And I have never printed flexible material with supports, so I don't know if the supports are gonna stick or fall apart, or if the supports are gonna be permanently stuck on, or if I have to cut them off. I have no idea. So it's kind of up in the air. I've never done flexible material with supports, and I know it's not recommended, so we'll see what happens. And I'm hoping my little piece of tape here is big enough so we don't have overlap. So I already lost one print bed, which has now become a cool GoPro mount, but hey. Alright, here we go. And I don't have any kind of time-lapse rig right now. I could, I don't know, try and rig up something with the tape. Oh yeah, and then one other thing, tune. I always go to Flow 105 to make sure it gets a good solid bond. So it looks like we just made it just right. You can see my outline, and then we also kind of look at how flat it is. Like, is it too close to the tape, too far from the tape? It's sticking really well, so we're gonna leave it alone. And unfortunately, I can't just sit here and let it, you know. So I'm gonna edit video while it's running, and I gotta kick the cat out because I don't want him playing with it and getting burnt. So I want to wait for it to start. I always watch the whole first layer. Now the only problem with this is this stuff is super slow, so it's printing the support material first so the support material can cool down and hopefully not stick to the stuff that you want to keep. It's a very smart printer. I just wish I had the Mark III because it would be more stable. The Z-axis on this thing's not very stable, and also my firmware is way out of date, and I need to get my Surface laptop, whatever, and plug it in and update the firmware on this. I just don't want to deal with it. Hi. 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 What are you doing? Ah. I'm gonna have to kick you out. I'm gonna have to kick you out, okay? I know you don't like it. Ah. Okay, go. Okay. He's one of those cats who would just like start playing with it, and I caught him playing with a roll of filament before that I forgot to put away. So I definitely don't need him getting caught in the printer and getting burnt, because it'd probably do some pretty serious damage. Okay, here we go. So now we're doing... I think printing 2 parts at a time is not a good idea for strength. No, it's definitely not a good idea for strength because we're trying to prototype and we're trying to see if this even works and if our dimensions need to be bigger or smaller. I just want to do it fast. So printing them both at the same time saves me setup and cleanup time. Okay, it looks like everything's working great, so I'm just gonna leave it here. I'm gonna go edit video and come back, and I apologize I can't time-lapse it. I need some kind of time-lapse rig, and I don't really have one. I mean, I could try to half-butt set up a... Let's see if I can do that.